All right, in the last podcast or two here, we're going to talk about the limitations or problems of fiber optic. Up till now, we've talked lots of good stuff about fiber, distances, bandwidth, immunity, EMI, RFI, all that jazz. But we want to recognize some of the limitations or problems with fiber optic, other than just cost and more expensive, that sort of thing. So, just reminding us the advantages of fiber, as we said, great distances, high bandwidth, immune to EMI, RFI, high security, all that good stuff. Disadvantages, the big ones we talked about were cost of the fiber, cost of the terminations, that sort of thing. Tougher to terminate, more fragile, that kind of good stuff. So we remember that we're really using it for distances, we're using it for bandwidth, we're using it for connecting closets, we're using it for high security areas. Okay, we know all that. But what are the actual problems with fiber? What are some of the limitations? Well, the big ones are loss or attenuation due to scattering or an absorption or dispersion. Well, let's look at those. Let's look at scattering, absorption, and dispersion. These are all problems with fiber. The first one we run to is scattering. And scattering occurs because of impurities or irregularities of the optical fiber. Well, as we said before, the Keck, Maurer, and Schultz at Corning figured out how to make fiber optic super clear by making it from a gas. So a lot of this issue went away when they started making fiber optic from a gas. We've reduced the amount of impurities, very negligible amounts of impurities in the glass of the fiber optic. Great. But we still can get some scattering. Well, let's understand scattering a little bit, then we'll come back and talk about, okay, what are we doing, how do we avoid it kind of thing. Well, the one we typically encounter is Raylene scattering. Raylene scattering? What the heck is that? Well, you actually know what this is already. We just don't think about it, or we have not put it in formal words. If I just had white light directly from the sun, it would just appear as white light. But as the white light comes through our atmosphere, it tends to scatter some and we get blue skies. That is your everyday common occurrence of Raylene scattering. Well, we get Raylene scattering also in our fiber optic. Let me show you what scattering looks like and what the problem is. All right, so I'm going to, in the next video, podcast here, I'm going to show you this, but let me talk you through what I'm going to do. I'm going to take water and run it through. I'm going to take a tank of water. I'm going to shoot my laser light through it. And I'm going to start off with distilled water. Distilled water because distilled water is made from a process, distillation. They make water from a steam, if you will. And with that, my impurities in the water are almost nil. So as I run the laser through the tank of distilled water, I'm probably not going to even see the laser light, because there's nothing there no minerals in the water to scatter the laser beam, so it's almost going to be invisible to us. And then what I will do is I will start adding things like salt and scattering solution. Scattering solution is really, think of that almost like coffee creamer. That contains proteins, very complex a molecular structure that as the laser light hits it, it's going to start scattering. And now it'll become visible. All right. So I'll talk more about this as I'm doing it, but this is one of the first problems of fiber optic. Irregularities or impurities in the glass can cause scattering. And scattering means the light is being broken into pieces and it's not getting to the other end of the fiber. It's weakening, it's attenuating. So if I have too much scattering, the light never makes it to the other end. All right. As I come back in the next podcast, I will show you Raylene scattering.